Alright, so good evening everyone. Welcome to this session of the Webcast Wednesday. First of all, is everyone able to hear me? Alright, so this is the telephone number on your screens right now. For attendees in India, you can dial 1800-425-4061 and follow it by the PIN number of 507248 hash. For people outside India, the number is mentioned there, followed by the hash key, the PIN code. Alright, so I hope my voice is clear to all. We will begin once I get a confirmation. Okay, so let's start today's webcast. We are going to see a very interesting topic today, which is LabVIEW X Controls. So we'll start off the webcast by first wondering like what all can be the uses of an X control. I'll show you one small example and then we will ask some questions as to how that can be done using X controls, and then we'll dive into what really X controls are, how do you create them, and what are the details of these. So let's begin with the topic, that is LabVIEW X Controls. So the first question that comes to our mind is what really are these X controls? So to answer that, I would like to show you a small scenario first. Now have a look at this VI. This is a simple front panel which has got a start button on the front panel. It's simple VI. Its block diagram has no code whatsoever. We will put some slight code into that, and let's just discuss the situation. So just hold on, I will open up the project for you. Okay, so this is the VI that I am talking about. Alright, let me put a very simple start button on the front panel. Okay, this is the start button. Now what I am going to do is I'll place some small code on the block diagram. Very simple code. All it is supposed to do is display us a message, a user message saying that the VI ran successfully. What I'm going to do is, so my intention here is when I run the VI, the main operation should not start until I press the start button. And only when I press the start button, the further execution should happen. And the further execution in our case being very simple, just a display of a dialog box. One easy way I could do this is like so. We need something. Suraj, we need something. Right, so I'm going to place a while loop in my block diagram. The while loop will keep on running continuously till I press the Boolean button. The moment that button is pressed, this dialog box is going to be displayed to me. So let's go ahead and check this VI. So now the dialog box is not initially popping up. Only when I press this button will the dialog box be popped up. Now one question I have for all of you: can I have a situation where I will have the button and the VI is currently not running. The VI should start running only when I press the button, right? So the question that I am asking is, in the VI that we just saw, we had to click the run button, wait for that while loop to run infinitely, and only when I press the Boolean button will the further execution take place. So now let us try thinking how it can be possible to make a control which on clicking will directly start running the VI. I need not have the VI already running. So we'll be discussing this, how to do that using X controls. So now let's get down to really answering this question, what LabVIEW X controls are. They are a special type of control in LabVIEW which have four main components that we'll be discussing about. And overall, you can just think of them as a set of VIs which have been packed into a library, and they are represented by a single icon on the block diagram. So as you know, in LabVIEW, any front panel object you drop can either be a control or an indicator, and it has one single terminal on the block diagram. Similarly, X controls are also simple controls. You can represent them with a single icon as a terminal on the block diagram. And the use of these things are they really save on your space in the block diagram, and we'll see how they do that. Next is they can be reused in other VIs. So you can create an X control in one LabVIEW project, save it, and you can reuse it in other VIs. And plus you can define your own functionality to that. For example, the Boolean button which I just dropped on the front panel, I can define it that whenever the user clicks this, no matter when the VI is running or not running, it should perform some action. Right. Now let's see how you can create X controls in LabVIEW. So I hope the overall idea, like the big picture of what an X control is, I'll just repeat that once again. They're basically a set of VIs, you can say, which we compile into a library, a LabVIEW library, and these set of VIs define a control. And these VIs act like the brain behind the control, and the icon still appears as a single terminal on the block diagram. So if you right click on my computer on your LabVIEW projects, you can go to new and you can say X control. You can either do this, or what you can do is in your VI, you can just go to file, you can just go to new, and the window which will come up will have an option of X control, right? Now when you create a new X control, a blank default LabVIEW project is going to open up, and in a while I will just show you how that project looks. Right, so this is how your new X control will appear. It will have some default name, and it will have four components inside it. So data, state, facade, and initialization. So let me discuss one by one what these components are. So there are mainly four components as we saw. Each of these is called an ability. So in LabVIEW terms, this is called an ability of the X control. So data is one ability, state is another ability, facade is another ability, init, short form for initialization, is another ability. And not only these four default abilities which are there in all X controls, you can add new abilities to the X control also from the project. How you can do that is right click your X control library in your project and go to new and say ability. So this is how you will do that. Let's say this is your project window. By default there are four abilities you have. You just right click on the X control, say new ability, and it will open up a window like so. So data, state, facade, and initialization are the default abilities which are always enabled. You can also add these abilities, other abilities, to your control. Right. So now let's get down to seeing what these abilities really are. Let's start off with the data ability. Up till now, everyone is with me. Any doubts you have? All right. Let's continue. So let's start with the first ability. Now, as we've seen, there are four abilities that every X control has. Let's start out with data. Now, if I go and open up data for you, you will see that it is nothing but It is nothing but a type definition. It is a type definition which has a particular control. Now this control can be anything. I can make a boolean also as the data. Now what this ability really tells us is what is the data type of my control. If your control, if the X control that you're making, you want it to handle only floating point numbers, then you can add a floating point, that is a numeric control here. If you wanted to handle boolean data, you can put a boolean control there. So any LabVIEW data type can be defined as the X control data type. However, there is one restriction. You can only place one data type at a time. So you cannot place two numeric controls on the data ability. If you want to work with complex data types, what you have to do is you have to make use of clusters and waveforms, which are basic standard LabVIEW elements. So that is the first ability, that is data. It is a type definition which defines what is the data type that X control is going to handle, right? Now the next ability, we call it state. Now what this does is it contains certain variables which we can use to control either the appearance or the behavior of an X control. So let me open that also and show you. This is the state ability. This is the state ability of my X control. So again, it is a type definition, and how you can use this is, let's take a simple example. Let's say you have an X control which is basically a knob. It is a knob which decides the speed of a car. So if I have the knob set to 10, the speed of the car should be 10. Now one thing I missed here is what are the units of this knob. It can either be kilometers per hour, or it can be meters per second, or it can be miles per hour. So X control gives us the ability of putting our own algorithm and behavioral dependencies in the X control. So how we can do that is using state. I will put a boolean here, for example. Let's say I put a checkbox here, which I will call, let's say, the units of speed. So what will happen is, later I will show you how to design the X control. These things we are doing for as properties of X controls, you can say. So when I make the X control, when I make its front panel, I will have a checkbox there which will say the units of the control should be either kilometer per hour or not. So depending on that, I will be able to change the units of my control, and that can happen because I have defined a state here which is units of speed. Right? So it will be more clear to you once I show you the complete demonstration. So that is the second property, that is state. The next is init. Init stands short for initialization. What this stores is the previous version, the previous display, and the container state. So this ability is called whenever you drop the X control on the front panel or load a VI into memory which uses this X control. So if you have saved the X control, the moment you drop it in a new VI, what LabVIEW does is it calls this initialization VI. Initialization is a VI, unlike data and state, which were type definitions. This is a full-fledged VI. Now what this VI does, whenever you drop an X control, this VI is called. It checks what is the version of the latest, version of that X control. If LabVIEW realizes that there have been certain changes that you have made and you have saved it into a new version, then the initialize VI automatically takes care of updating that X control. Right? Now, one very important use of this is, let's say you have used your X control in a lot of VIs. Now you make some changes. You change the data type, or let's say you change the behavior a bit. Whenever the person who has used this X control opens his VI, first thing that the LabVIEW engine will do related to the X control is it will check the initialization VI that this person is using this version of this X control. Let me check what is the latest version. If they don't match, I will update his X control to the latest version. So this is a simple snapshot of how the init VI looks like, the initialization VI. As you can see, it tells you what is the previous version, and it gets the current version that the user is using. If these two do not match, or if these two match, then you can take some steps. You can update his state based on the latest version. So again, if you open the LabVIEW project which we had for the X control, here if you open the init VI, okay, you will see that the similar block diagram appears, and everything is well documented, and everything, most of the inputs and outputs are already present to us. You just need to follow this documentation. There are free labels at all appropriate places. You have to just put your code inside. Okay, so that was about the init, that is initialization ability. Next, and the most important ability of an X control is the facade VI. So the facade VI is the main brain behind the X control. It defines how the X control is going to appear, what is the behavior of the X control, and the front panel of this ability is what defines the face of our X control. Whatever I place on the front panel of this facade VI is how my X control is going to appear. And it by default provides 3 inputs and 3 outputs for modification. We'll be seeing them in a while. These are data in and out, display state in and out, and container state. And this VI has an event structure where we can develop our logic, right? So let's revise all of these components with the help of our original problem, the problem that I had demonstrated, the problem that we had posted initially. So as we have already seen, I run this VI, I click the start button, it shows me a dialog box. Now my requirement is the user should click on this button and directly that VI should start running. So let's solve this problem by making use of X controls. So what we'll do is we'll go ahead, we already have one X control here created. We go ahead and remove this one. Right. Now I will first of all go to the data ability of this X control, and I know that I want it to behave like a Boolean button. So I'll remove this and I will put a simple Boolean button there. So now the data type of my X control has been defined as a Boolean. Fine. That is done. Let's open state and check what is there. Currently I am not specifically looking at anything from the state point of view, so let me go ahead and remove this that I had added. You just let it be whatever is there default. Next is the facade VI. This is the most important part of the X control. Now by default it will have certain steps on the front panel. Let me go ahead and remove them. You can read them later at your end. What I'll do is I'm going to add a Boolean button which is going to be my X control. Let me resize my front panel so that it just fits this Boolean button. And now another feature is when I save this, the default size of my X control is going to be this much. If I want to give the ability of resizing, then I can right click and say scale object with pane, so that if someone changes the size of the control, like here, when I change the size, it scales. So to give that feature, I will mention there in the facade VI as scale object with pane. Now let's have a look at the block diagram. So this is the block diagram that we get, and this is, I have not done any programming by default. This is there as soon as you create an X control. The template is already ready, you just have to fill in your code. Now let's have a look at the event structure. First of all the inputs that we had discussed are available to us. You have data in. If I go ahead and open context help, you will see what are the components of data in. So remember, in the data ability we had defined this X control to have a Boolean data type. So you can see data in is a type definition which just has data in, which is a Boolean. Next is display state in. We didn't really touch that because we are not going to use it in this demonstration, but you can see that the display state type def, whatever you have put there will appear here. Currently we just have a numeric. Container state is something which tells the facade VI what is the current state of this X control. So is the user using it as an indicator or as a control? Is the X control a part of a VI which is currently running, or is it in edit mode? And third, it returns the ref num, right? Then you have this major event handler, which by default has 5 cases, 5 events: timeout, data change, display state change, direction change, and execution state change. So if you notice, the timeout has a 0 wired to it. So I'll be asking you a question on that later. You can just think about it. So inside every event case, they have described when that event is triggered. It will be, so the data change will be triggered whenever a value is written into the X control. or through local variable or a value property change, somehow anyhow the X controls value changes, the facade VI will automatically be called and this event will be executed. Next event that it handles is the display state change. So any sort of state from the display point of view, if it changes, this event is triggered off. When all does this happen? When we drop a new instance of the X control, immediately this event is triggered. If we copy or undo an operation, this event is triggered. Or if we are executing a custom property or method on this X control, again this event is triggered. So everything is well documented also, you can read it. Next is direction change. If someone changes a control to an indicator, which is an instance of this X control, again this event will be fired off. Next is execution state change. So if the VI in which I am using this X control, if I change it from edit mode to run mode, then this event will be configured, will be triggered off. And I can here put whatever code I want. I can define the running or the algorithm of my X control. So what we are going to do is, we are going to add one more event here. So you can see the edit events window is going to come up. I am going to select the button that I had added on the front panel and I'm going to configure a value change event. So my intention is whenever the user clicks on this, a value change event is going to be fired off, and I want the owning VI, wherever I have placed this X control, I want it to start running. So what I'm going to do is, I'm going to minimize this. I don't need all of these. I'm going to use an unbundle by name, right? I'm going to find the ref num, the reference number of that X control. Using this reference number, I will find out what is the owning VI. This will give me the reference number of the VI where this X control is placed. And as you might have, some of you might already know, these things that I'm using are called properties and methods. So you can read more about them on our website ni.com. You can also head over to our Webcast Wednesday page. There have been previous webcasts on these. So there is a method for every VI, which is the run VI. So I'm just going to drop that here. All right. One second. Yeah, this is the reference that I want to wire. That is done. So that's it. I think my X control is ready for saving and trying it out. Let me go ahead and check everything is alright on the front panel. Yes, looks good. Let me go ahead and save all my changes. Alright. Now that my X control is ready for use, what I'm going to do is I'm going to go back to this VI. Let me remove this button and let me drop my X control. Now how I can do that is just drag this control from the project to the front panel. Now I have to do some modifications on the block diagram. If you can see, this is the terminal for the X control. Now you can see that how this can help in saving block diagram space. A huge chunk of algorithm event structure has just shrunk into one terminal. Now I no longer need this while loop. Oops, let me drop the X control again. I no longer need any while loop now. So the moment, so one thing maybe what I can do is just time this. Alright, so now you can see there is no while loop anywhere. I just have this X control and I have defined the X control in such a way that whenever its value changes, just by pressing it, the facade VI will be called and it will automatically start running the owning VI. Let's see it in action. I'm going to click this and you can see the VI started running. So even though I did not click the run button, because of X controls, I was able to implement this functionality. You might have noticed the event structure which was there inside the facade VI. So I'm going to ask you a question related to that. So there was a timeout case that you might have seen, which was there in the Facade VI. So do you know why there was a 0 which was mentioned there? So I'm going to launch this poll. Why do you think a 0 was wired to the timeout event, to the timeout of the event structure? Is it because the event structure we do not want it to wait at all, or do we want to reduce the response time of our X control, or do you think both are valid reasons? Alright, so most of you are going with option A. The next winner is all of these. So I'll tell you the correct answer. It is all of these. We do not want our X control to have a lot of response time. So if I put a timeout there of 10, even if someone clicks here, if it is currently executing the timeout case, it will have some amount of response time. We do not want that. Hence we have put a 0 in the timeout case, in the timeout event structure. Alright, so now that we have understood the basics of X control, what I'm going to do is I'm going to show you what I have in store as the contest of the week. So here is the contest. Let me first explain what you have to do. Alright, so here is your contest. What you have to do is you have to create an X control, which is basically a stop or a quit button, and irrespective of whether the VI in which it is dropped is running or not, whenever I press this quit button, a splash screen should come up on the screen and the VI should end. So for example, this is the splash screen. Let's say this is the VI. Whenever I click on this, the splash screen should come and the main calling VI should be closed. So that is the contest. Just try creating this X control, and you can drop it to us in the as comments. And just as a new thing, we have revamped our design a bit. The Webcast Wednesday page, we have revamped its design. So I just want a quick feedback from you on the design. How many of you all think it's an improvement? How many of you all think it's not really that great? Or how many of you are not aware of the new design change that we have done? Alright, so most of you are not aware. So what I'm going to do is I am posting the link here. This is the link which I have posted now. We have made it more content oriented. So the moment you click on this, you land on the webcast page with the previous week's recording and contest, and there will be a hyperlink there. If you click on that, it will take you to the contest page where you can drop your answers as comments. The current contest is going to be open in a short while, and I'll be uploading the recording also. So I think that's all from my side. Hope you all enjoyed this webcast, which was on X controls. I hope you'll try implementing it in your applications. It's got a lot of fun features that you can explore. Let me give you a link of a good white paper also, which talks about this. So on your chat windows right now, I have pinged the link of a white paper, which is a very good starting point for learning about X controls and using them. So this is the problem statement of the contest of the week. It will be up soon on our page, on our new page. This is the new link of that. Thank you. Hope you enjoyed this session of webcast. Do join us next week for the next session.